وعلى آله وصحبه أجمعين. We are in chapter 6 now. This is section 6.2, and chapter 6 is a continuation of chapter 5. So it's also about trigonometric functions. We will learn here in this section how to find the sum and difference of two angles. So we will talk about sum and difference formulas. If you remember, we studied in chapter 5 this triangle, the 30-60 triangle. So this angle is 30 or pi over 6, and this angle is pi over 3 or 60, and this is the hypotenuse. So if this number, if the length of this side is 1, then the length of this side is 2, and the length of this side is square root of 3. And using this triangle and without a calculator, we can find the 6 trigonometric functions of pi over 6 and pi over 3. Also, we studied, or we have seen, another triangle, 45 triangle, pi over 4 and 90. If the length of this side is 1, this is 1, and this is square root of 2. And using this triangle, we can find the 6 trigonometric functions of pi over 4. And now the question, are there any more angles we can find their 6 trigonometric functions without using a calculator? And the question is yes, using these formulas. For example, look to this formula, cosine alpha minus beta. So for example, if we need to find cosine 60 minus 45, what would be cosine 60 minus 45? Is it going to be cosine 60 minus cosine 45? And the answer is no, this is not correct. And the reason, you can find out 60, you can use the calculator to find out. This is 60 minus 45, this is cosine 15. Find whether cosine 15 equals to cosine 60, which is half minus square root of 2 over 2. So is it 1 minus square root of 2 over 2? Is cosine 15 equals to this? And you will find no, the answer is not correct. So cosine 60 minus 45 is not equal to this. You can, if you like, try with known angles. For example, I can say try cosine 90 minus 45, or 1. Okay, you can check, you can search for any two questions like this, just to make sure that cosine alpha minus beta is not in general equal to cosine alpha minus cosine beta. So that's not correct. So what is the correct formula? Okay, that's the correct formula. If you have cosine alpha minus beta, it is equal to cosine alpha, the first angle, times cosine beta, the second angle, to cosine times cosine, and then you change the minus to plus, and then you have sine alpha sine beta. So cosine cosine plus sine sine. That's sine cosine alpha minus beta. So for example, we can talk about cosine 15 now. Why can we talk about cosine 15? Because 15 is the difference between 60 and 45. Or you can use 45 and 30. So cosine 15 is equal to cosine 60 minus 45. And now you can use this formula to find the exact value of cosine 15 without using a calculator. So use the formula. It would be cosine 60 cosine 45. So cosine cosine minus sine 60 sine 45. cosine, cosine, minus sine, sine. And you know how to find all of these. So cosine 60, for example, using this triangle is half times cosine 45, which is square root of 2 over 2, 1 over square root of 2, rationalize the denominator, minus sine 60, square root of 3 over 2, times sine 45, square root of 2 over 2. Now you multiply these two fractions, so you get square root of 2 over 4, and you multiply these two fractions, you get square root of 6 over 4, and then you subtract. You have the same denominator, so the answer is square root of 2 minus square root of 6 over 4. That's the exact answer of cosine 15. You can evaluate this by the calculator and evaluate cosine 15 by the calculator and make sure that, yes, this is indeed the exact value of cosine 15. So why we are studying sum and difference formulas? Because these formulas enable us to find cosine 15. Cosine, for example, 105 if you add 60 plus 45. So if you take these three angles, which we know, 60, 45, 30, subtract any two of them, add any two of them, you should be able now to find the cosine, the trigonometric functions of the new uh, angles. Another example, we know that cosine 30 is square root of 3 over 2. Obtain this exact value using cosine 30 equals cosine 90 minus 60 and the difference formula for cosines. Difference formula for cosines is this formula. This formula is called difference formulas for cosines. All right. So cosine 30 equals to cosine 90 minus 60. Use the formula. Cosine plus, the formula is plus, not minus. So there is a mistake here. This is a plus, this is a plus, this is a plus, and here you have plus. Remember, in the formula minus, and here you have plus, opposite sign. So cosine 90 minus 60 would be cosine cosine plus sine 90 times sine 60. Okay, how to obtain cosine 90? If you remember the quadrantal angles, we obtain them from this circle, these 4 points, 0, 1, 1, 0. So 90 pi over 2 here, cosine 90 is 0 because here cosine is x, sine is y because r is always 1. So cosine 90 is just 0. So cosine 90 is 0 times cosine 60, whatever the value is would be 0, plus sine 90 is 1 times sine 60. So this is 0 equals sine 60, and using the triangle, sine 60 is square root of 3 over 2. So this is cosine 30. It's equal to square root of 3 over 2. So we obtain the value of cosine 30 using the difference formula for cosines. Another example, use the formula for the cosine of the difference of two angles to find this cosine 3 pi over 4 minus pi over 6. Well, what is the formula? Cosine 3 pi over 4 times cosine pi over 6 plus sine 3 pi over 4 sine pi over 6. Now notice that cosine pi over 6, sine pi over 6, I can find them by from the triangle. But the problem was with 3 pi over 4, 3 pi over 4 is not pi over 4. Okay, so how to find cosine 3 pi over 4? I need to use the reference angle. If you draw 3 pi over 4 in standard position, then you will find that theta prime is pi over 4. And 3 pi over 4 lies in quadrant 2. And in quadrant 2, cosine is negative. Cosine is less than 0 in quadrant 2, okay? While sine is positive, okay? So we will have, we can write this equals cosine 3 pi over 4 would be equal to negative cosine pi over 4, the reference angle, because it is in the second quadrant, times cosine pi over 6. Now plus sine 3 pi over 4 would be equal to sine pi over 4, the reference angle, because sine in the second quadrant is positive, while sine is greater than 0 in quadrant 2. So sine pi over 4 times sine pi over 6. So this is what we did exactly in chapter 5. To evaluate cosine 3 pi over 4, we need to find the reference angle, and we use the fact that cosine theta equals plus or minus cosine theta prime. And now all the angles are the three angles we know. So we write the answer negative square root of 2 over 2. Cosine pi over 6 is half. Sine pi over 4 square root of 2 over 2. Sine, no, cosine pi over 6 is not half. Cosine pi over 6 is square root of 3 over 2. This is pi over 6, and cosine pi over 6 is square root of 3 over 2. Sine pi over 6 is half. So the answer would be multiply negative square root of 6 over 4 plus square root of 2 over 4. Add, the answer is negative square root of 6 plus square root of 2 over 4. So this is cosine 3 pi over 4 minus pi over 6. Now another example. Find the exact value of cosine 80, cosine 20 plus sine 80, sine 20. If you look carefully here without using a calculator, this question, cosine cosine plus sine sine, this means cosine alpha minus beta. Alpha is 80, beta is 20. So this is in fact cosine 60, and cosine 60 is just half. So that's the answer. Here also you have cosine cosine plus sine sine. So this is cosine alpha minus beta, or cosine 30, and cosine 30 is just square root of 3 over 2. Please solve this one similarly. Okay. Let me do this one, number 7. What are the questions here? Identify alpha and beta in each expression. He says each expression is the right side of this formula. Remember, this formula equals cosine cosine plus sine sine. So this is the right side, okay? So identify alpha and beta. So alpha here is what? Is 5 pi over 12. And beta is pi over 12. Okay, so this is part A. Part B, write the expression as the cosine of any angle. As cosine of any angle. So this would be equal to cosine, okay, cosine of an angle. Cosine what? Alpha minus beta. So 5 pi over 12 minus pi over 12. And 5 minus 1 is 4. So this is cosine 4 pi over 12. And 4 over 12 is pi over 3. So this is part B. Part C, find the exact value of the expression. Well, cosine pi over 3 is equal to half. So that's the answer. Now, all of these questions were about this formula only, which is the difference, cosine of the difference of two angles. What about cosine of the sum, or sine of the sum and difference? Here are the 3 or the 4 formulas. These are all the 4 formulas. This is the one we studied, number 2. Now, if you replace minus with plus, okay, this sign will change. So with cosine, the sign is different, plus minus minus plus. With sine, you don't have cosine, cosine, sine, sine. You have sine, cosine, cosine, sine. So sine alpha, cosine beta, plus the same sign here, okay? Plus cosine alpha, sine beta. If you have a minus, you have sine alpha cosine beta minus cosine alpha sine beta. These are the 4 formulas you need to understand and memorize. And all of the questions in this section are about these formulas. So for example, find the exact value of sine 7 pi over 12 using the fact that 7 pi over 12 is pi over 3 plus pi over 4. Good. So we need to find sine 7 pi over 12. And he told me that 7 pi over 12 is pi over 3 plus pi over 4. Good. Now use the formula of sine. This is the formula. Sine alpha, so sine the first angle, times cosine the second angle, plus the same sign. Now, cosine the first angle times sine the second angle. And pi over 3 and pi over 4 are known to us, so just write the answer. Sine pi over 3 square root of 3 over 2. Cosine pi over 4 square root of 2 over 2. Cosine pi over 3 half. Sine pi over 4 square root of 2 over 2. Multiply, add. So this is the answer. Square root of 6 plus square root of 2 over 4. Please find the exact value of sine 5 pi over 12 following the same steps. Also, do this one. Remember, this is sine 15. 45 minus 30 is 15. So now we can talk about 15. Let us do sine 105. 105 is not one of the 3 known angles. It's not 30, it's not 45, it's not 60. So how can I find sine 105? I immediately think of the difference or the sum of 2 angles. Now, you do what? You take 1 over 105 and subtract 105 minus one of these angles. So for example, if you subtract 105 minus 45, you will get 60. Then you understand that I can write 105 as 60 plus 45. And once you can write it like this, you can use the formula and find the answer. So what is the formula? Sine the first angle, cosine the second angle, plus cosine the first angle, sine the second angle. And you put the values and continue the question. What about cosine 135 plus 30? Let us do this question. Now this is cosine. So remember, you have to memorize the formulas. It is cosine 135, cosine 30, and the sign is different. So plus minus sine 135 sine 30. Please pay attention to this question, okay? Because this is 135. It is not 30, 45, or 60. So this question is important. This question is important when you ever study this section. Please, you have to study this again. And also, this question is very important. The one we solved here, this one, because this is 5 pi over 12. Okay, this is 5 pi. No, not this one. Sorry, this one, this one, this one. 3 pi over 4. See what did we do here? This is very important. Usually in the exam, if he is going to bring one question about this section, it could be this question, because such kind of questions will see whether you understand also chapter 5 or not. So 135, you cannot find the answer using the calculator. 135 is not 30, 45, or 60. You have to draw the angle 135 in standard position. And this is 135. The reference angle of 135 is 180 minus 135, which is 45. So again, this is in the second quadrant. In the second quadrant, quadrant 2, cosine is negative, sine is positive. Cosine 135 would be equal to negative cosine 45 times cosine 30 minus sine 135 would be equal to sine 45 times sine 30. So sine 135 is sine 45, cosine 135 is negative cosine 45 because 135 is in the second quadrant, and in the second quadrant cosine is negative and sine is positive. And now you continue as usual. You find negative square root of 2 over 2, cosine 30 is half, sine 45 square root of 2 over 2, sine 30 is square root. Actually, cosine 30 is square root of 3 over 2, and sine 30 is half. So the answer would be negative square root of 6, negative square root of 2 over 4. Cosine 75, I will leave it for you. You can just write it easily as 45 plus 30, and you continue using the formula. Write each expression as the sine, cosine, or tangent of an angle, then find the exact value of the expression. Look carefully. Sine, cosine, cosine, sine. And notice that these two angles are the same, so this is alpha, and these two are the same, so this is beta. So sine, cosine plus cosine, sine, this is sine alpha plus beta. So it's sine 25 plus 5, so it's sine 30, and sine 30 is half. What about this one? You have 5 pi over 12, 5 pi over 12, this is alpha, beta pi over 4, pi over 4, cosine, sine cosine minus cosine sine. So this is sine alpha minus beta. So sine 5 pi over 12 minus pi over 4. So this is sine 5 over 12 minus 1 over 4. You can use the calculator, or this is 3 over 12. So it is 2 pi over 12, and 2 pi over 12 is just pi over 6, and sine pi over 6 is just half. Okay, please do this one similarly. Now the last point in this section, the last type of examples would be examples like this, and pay attention to this type of examples. Usually this example, this kind of examples, we ask about it in the exams. Suppose that sine alpha is 12 over 13 for a quadrant 2 angle alpha. Well, the first thing here is to sketch the graph of the angle alpha in quadrant 2. So this is the angle alpha in quadrant 2, and this is alpha prime, which is the reference angle of alpha. All right. Now, what do we know? We know that sine alpha is 12 over 13. Sine alpha is 12 over 13. What is sine? It is opposite over hypotenuse. Okay, so what is the opposite? 12. What is the hypotenuse? 13. We need to find the adjacent. How to find the adjacent? It is square root of, using Pythagorean theorem, 13 square minus 12 square. Okay, so it is square root of 5, for 25, which is 5. Okay, use the calculator. 169 times 145, that's let us do it quickly, checking. 169 minus 145, yeah, 25 square root of 5. But put in your mind that we are in the second quadrant, so x here is negative, so the adjacent has to be negative. So the adjacent is negative 5. So this is negative 5. What does he need? He needs cosine alpha. Well, cosine alpha is negative 5 over 13, the adjacent over the hypotenuse. What about cosine beta? You do the same, but here beta is an angle in the first quadrant. So beta is an angle in the first quadrant. So this is the angle beta. Okay, what do we know? We know sine beta. Well, sine beta, the opposite is 3, and the hypotenuse is 5. Use the Pythagorean theorem to find that this is 4 square root of 25 minus 9. So it's square root of 16, which is 4. So the adjacent is 4. Now what do we need? Cosine beta. Cosine, you have the triangle of beta. You can find any trigonometric function of beta. Cosine beta adjacent over hypotenuse is 4 over 5. And now the question, find cosine alpha plus beta. Well, by definition, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And you have the triangle of alpha. So what is cosine alpha? Negative 5 over 13. What is cosine beta? Cosine beta 4 over 5. Sine alpha, what is sine alpha? It's given in the question, 12 over 13. You can also find it from the graph, the sketch. Sine beta, what is sine beta? 3 over 5. And then you multiply. This is negative 20 over 65, and this is 36 over 65, and then you add. So you have negative 56 over 65. That's cosine alpha plus beta. Please find sine alpha plus beta similarly using the formula of sine alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. Another question, same question, okay? And alpha is in quadrant 2 and beta is in quadrant 1. So this is exactly the same as the previous one. So please also do it at home. Let us solve other type of questions. This is a quadrant 1, quadrant 2. This is a quadrant 4, quadrant 3. So I'll do this one. Okay. I keep this, I leave this for you. We need to find same questions. We need to find cosine alpha plus beta, sine alpha plus beta. If you find this one, you can find this one. I'll find B. I'll find here sine alpha plus beta. He doesn't have to ask you about both. If you can find one of them, that's okay. All right. To find sine alpha plus beta, I have to sketch a graph for alpha and graph for beta first. But please pay attention. Where is alpha? Alpha in the fourth quadrant. So this is the angle alpha, and this is alpha prime, and this is the triangle of alpha. All right. What do we know? We know the cosine. What is the cosine? It is the adjacent. So the adjacent is 8, and the hypotenuse is 17. And we need to find the opposite sign. And put in your mind that the opposite sign is negative because y in the fourth quadrant is negative. So this would be negative. How to find it? Square root of 17 square minus 8 square. So what is the square root of 17 square minus 8 square? Calculator says 15. So 15. So you write here negative 15. You are in the fourth quadrant, okay? So what would be sine alpha plus beta? This is alpha. This is alpha. Let me have another graph for beta. Where is beta? Beta lies in the third quadrant. Good. So this is the angle beta in standard position. And this angle is beta prime, the reference angle of beta. All right, what do you know about beta? I know that the sine is negative half. Well, the sine is the opposite over the hypotenuse. The hypotenuse cannot be negative, so the opposite is negative 1. And you can see that, yeah, the opposite here has to be negative because y in the third quadrant is negative. All right, and this is 2. Now, what about x in the third quadrant? Is it positive or negative? It's negative. How can you find it? Square root of 4 minus 1. Negative 1 square is 1. So it's square root of 3. So I have here square root of 3, but it has to be negative. So the adjacent is negative square root of 3. Now I have the alpha, triangle for alpha, triangle for beta, so I can find anything. So sine alpha plus beta by definition is sine alpha cosine beta plus cosine alpha sine beta. It would be equal to. Now, what is sine alpha? Here, by definition, use the triangle opposite over hypotenuse. So it's negative 15 over 17 times cosine beta, go to beta, cosine adjacent over hypotenuse, negative square root of 3 over 2 plus cosine alpha 8 over 17. It's also given in the question. You can use both times sine beta is given in the question, or also from here it is opposite over hypotenuse, so it's negative 1 over 2. Now the answer would be 15 square root of 3 minus 8, 1 times 8 over 2 times 17, which is 34. That's the answer. This is an important question. Please pay attention to it. And especially you need to pay attention to the quadrant. Is x positive or negative inside that quadrant? Let me also conclude this lecture by solving this question. This is the last question. Tan alpha is 3 over 4. And alpha is from pi to 3 pi over 2. All right. So where is pi? This is pi. And this is 3 pi over 2. So when he says that alpha is between pi and 3 pi over 2, this means that alpha is in the third quadrant. And this is alpha prime. And this is the triangle of alpha. What do we have? Tan alpha 3 over 4. Tan alpha, please pay attention. There is a trick here. Tan alpha is 3 over 4. Well, tan is y over x. We are in the third quadrant. This should be negative, the opposite. It cannot be 3. So I have to write 3 over 4 as negative 3 over negative 4. Negative over negative will give you positive. Why? Because the opposite is negative and the hypotenuse is negative. Use the Pythagorean theorem to find that this is 5. So you have the angle of alpha. Okay. Now let us draw the angle of beta. Where is beta? From 3 pi over 2. This is 3 pi over 2 to 2 pi. So beta is in the fourth quadrant. Good. So this is beta and this is beta prime, the reference angle of beta, and this is the reference angle. This is the triangle of beta. What do we know? We have the cosine. Cosine beta is the adjacent positive over the hypotenuse positive, and you find this which is negative. How to find it? Square root of 16 minus 1. So this is negative square root of 15. What do we need to find? We need to find sine alpha plus beta or cosine alpha plus beta. So please at home find cosine alpha plus beta using these two triangles. This is the end of this lecture. Thank you very much. And if you have any question, please